When you get to learning things like calculus, every step you take is just as important as the one before it. Chain rule is one such step. During the derivation process, the chain rule is used to split apart a confusing conglomerate into separate, easily determined pieces. Chain rule can be compared to many things, but we picked out 3 of our favorites in order to help y'all visualize it better. Up first, a nature value bar. No matter in which state of disarray, this one's a little crumbly, the nature value bar will always have 2 parts, and usually it's easier to eat if you separate them. An exception in calculus would be if the variable in the question was simply x, not x squared, or, God forbid, the square root of the sine of 3x. That's a little bit more difficult. Up next, we got Russian stacking dolls. Outside this seems simple, a doll. Let's compare it to the equation, the square root of the sine of 3x. We need to break this apart. The outermost derivative ends up being 1/2 sine of 3x to the negative 1/2. Then we go in and find the derivative of sine of 3x, which is cosine of 3x. But wait, there's more. Since 3x is not x, we have to go a step further and pull out 3x and derive that, which is 3. And then we multiply them all together. And that will be our completed derivative. And after that painfully obvious cut, a clock. Look at an analog clock in your everyday life. Mine is on my phone. It still technically counts. Likely it'll have 3 different hands on it, an hour hand, a minute hand, and a second hand. They're all independent and not glued together or anything, but they work in tandem to keep the time running smoothly. The innermost equations, like the seconds hand, matter just as much as the slow movements of the hour hand. And that's the chain rule. Hope you enjoyed.